All right, today we're going to also cover lesson 4.6, the associative property of multiplication. We're on page 161 of your textbook. The essential question for our lesson is, how can you use the associative property of multiplication to find products? So what do we know about the associative property? Well, you've learned the associative property of addition, and when the grouping of the addends is changed, the sum stays the same. So here we have 2 plus 3 being grouped, plus 4, and then they switch the grouping, and in this case they have 2 plus the sum of 3 plus 4. But regardless, no matter how you do this, you would get 9. So the associative property of multiplication states that when the grouping of the factors is changed, the product is the same. It is also called the grouping property of multiplication. So again, we're going to use the same numbers. This time we'll have multiplication, 2 times 3 times 4, 2 times 3 times 4, but how they're grouped is differently. On the left-hand side, we have 3 times 4 grouped, and on the right-hand side, we have 2 times 3 grouped. So on the left-hand side, we have 3 times 4, which is 12. 12 times 2 is 24. On this side, we have 3 times 2, which is 6 times 4, and 6 times 4 is 24. So we see that it doesn't matter how they were grouped. We're using the same factors, so we have to remain and get the same product. Unlock the problem. Each car on the roller coaster has 2 rows of seats. Each row has 2 seats. There are 3 cars in each train. How many seats are on the train? Or on each train? Underline what you need to find. So, I need to find how many seats are on each train. Describe the grouping of the seats. So we have 3 cars with 2 rows of 2 seats. Okay, and one way we can solve this is to use an array. And so we see that we have 2 rows of 2, 2 rows of 2, 2 rows of 2. So these rays represent 3 cars. You notice that there's a space in between. So we have 3 groups of 2 times 2. So 3 times 2 times 2 is 4. So 3 times 4 is 12. So there are 3 cars with 4 seats in each car. So there are 12 seats on each roller coaster train. Okay, we can also change the grouping. So instead of going 3 times 2 times 2, we could say 3 times 2 first, which would be 6, and then 6 times 2, which is 12. We'd still get, again, the same product. So however you want to set that up. All right. Page 162. We could also use the commutative and associative properties to solve. So on the left-hand side here, we're going to have an example of the associative property. On the right-hand side, we're going to use both of those properties to solve a problem. So here we have 4 times 3 times 2, and they've grouped 4 times 3. But using the associative property, I could also say 4 times the product of 3 times 2. So 3 times 2 is 6, 4 times 6 is 24. Okay, we have the same factors on both sides, But you notice here that instead of going 3 times 2, they switched it to say 2 times 3. It does, again, it doesn't matter, but in a sense they're saying, well, I think it's easier to say 2 rows of 3 than 3 rows of 2. Again, these are just an example. I'm not certain I would necessarily change that. It's 3 rows of 2 or 2 rows of 3. There's really no difference as far as difficulty, but there's just demonstrating. So again, 2 rows of 3, but then they said, what if instead of doing 2 times 3 first, what if I do 4 times 2 first and then multiply 3? And so in that case, we have the same factors, same order, but they switched how they were grouped. So now the person that's solving this wants us to do 4 times 2 first. And 4 times 2 is 8. So 8 times 3 would be 20. All right, so number 1, find the product of 5, 2, and 3, and write another way to group the products. Group the factors. Is the product the same, and why? So we could have 5 times 2 times 3 grouped that way, and 5 times 2 is 10, and 10 times 3 is 30. The other way would be 5 times 2 times 3. So we have the same factors, same order, but we need to group them differently. So in this case, I'm going to group the 2 times 3 first. And 2 times 3 is 6, so 5 times 6, or 6 times 5 is 30. They are the same product. This grouping does not change the product. Okay, find another way to group the factors, then find the product. So here, instead of doing 2 times 1 times 7, I could say 2 times 1 times 7, and 7 times 1 is 7, and 2 times 7 is 14. Number 3, we're going to have the same factors, same order, if we're going to use a different way of grouping them. And here we have 3 times 4 grouped, so we're going to switch and go 3 times 3 being grouped. 3 times 3 is 9, and 9 times 4. 9 times 4 is the same as 9 times 2 doubled. 5 times 2 times 5, rewrite the factors in the same order. And instead of grouping 2 times, you'll notice that in this one, it actually winds up being the same. But they do want us to find a different way to group them. So let's do 5 sets of 2 instead of 2 sets of 5. And that wouldn't change that one. I would just go ahead and solve it. 5 times 2 is 10, and 10 times 5 is 50. 3 times 2 times 6, rewrite the factors in the same order. Just change your grouping symbols. Instead of 2 times 6, group 3 times 2. and we'd wind up with 6 times 6, which is a factor we should know. 6 times 6 is 36. Okay, number 6, rewrite 2 times 2 times 5. Put the grouping symbols around 2 times 2, and we'd wind up with 4 times 5 instead of 2 times 10. 4 times 5 is 20. 1 times 3 times 6. Instead of grouping 1 times 3, we could group 3 times 6. And 3 sets of 6 is 6, 12, 18. And we know that any number times 1 is that number. 18 times 1 is 18. Okay, page 163, number 8. Write another way to group the factors, then find the product. So 2 times 3 times 3. So we can group the 3 times 3 instead and go 2 times 9. 2 sets of 9, 18. Eight times 3 times 2. Instead of doing 8 times 3, we can say 3 times 2 first. 3 times 2 is 6. 8 times 6 is the same as 8 times 5 plus 8. So we have 40 plus 8, 48. 2 times 5 times 5. And we write that as 2 times 5 times 5. Right, so finish up number 9. 8 times 5 would be 40. Add the extra 8. 40 plus 8 is 48. Right, number 10, we rewrite the factors as 2 times 5 times 5. And so they're in the same order. We're just going to regroup them differently. Instead of grouping 5 times 5, let's group 2 times 5. And 2 sets of 5 is 10. And 10 times 5 is 50. Okay, number 11, 3 times 2 times 4. If we rewrite the factors in the exact same order, just changed how they're grouped. 2 times 4 is 8. 3 sets of 8 is 8, 16, 24. Number 12, you would still wind up with the same numbers in your final multiplication. But since we're practicing associative property, just go ahead and group 4 times 1 instead of 6 times 1. We'd still wind up going 6 times 4. And 6 times 4 is the same as 6 times 2 doubled, so 24. Number 13, 2 times 2 times 6. So originally they're grouping 2 times 6, so we can change that and group 2 times 2. And we'd wind up with 4 times 6. And we just solve that. So 4 times 6, 24. 2 times 4 times 2. Associative property again says that we can, doesn't matter which way we group our factors, we'll still wind up with the same product. And this one doesn't change anything because we're still grouping 4 with 2. So 2 sets of 4 is 8. 8 times 2 is 16. 5 times 2 times 4. We can group 5 times 2 instead and get 10 times 4. 10 times 4 is 40. 9 times 1 times 2. We can group 9 times 1 instead and go 9 times 2, which is 18. Right, use parentheses and multiplication properties, then find the product. So what we want to do in these problems is ask ourselves which factors would be easiest to multiply first. So would it be easier to go 6 times 5, then multiply by 2? Or would it be easier to multiply 5 times 2, and then multiply that by 6? So in this case, I believe it would be easier to go 5 times 2. 5 times 2 is 10, and then 10 times 6 is easy. 2 times 3 times 5. Actually, I think it's easier to switch the order of two of my numbers in this case, and instead say 2 times 5 times 3, and then group 2 times 5. So I use the commutative property to change the order of the 5 and the 3. So 10 times 3, I would get 30. So if you didn't do that, you could have grouped 2 times 3 and then multiplied by 5. That would have been just as easy. Okay, number 19. It's really not going to matter whether you multiply 6 times 1 or 3 times 1. So 3 times 1 is 3. 3 times 6, 3 sets of 6 is 6, 12, 18. 2 times 5 times 6, I like the idea of multiplying 2 times 5 first. 2 times 5 is 10. 10 times 6, 60. Number 21, it's not going to matter which way we group these, so just go 2 times 0 is 0. 0 times 8, 0. We can group 1 times 9 first and get 9 times 4. 9 times 4 is the same as 9 times 2 doubled. So 9 times 2 is 18. 18 plus 18, 36. 2 times 2 times 2. No matter how you group them, you're going to be multiplying the same exact things. So might as well just group the first two twos. 2 times 2 is 4. 4 times 2, 8. Okay, some of you might go and say, well, I'm going to multiply 2 times 2 first and then go 4 times 4. But I think going 4 times 2, which is 8, and then multiplying that by 2 is just as easy. And 8 times 2 is 2 sets of 8, which is 16. 2 times 4 times 5. Well, I know that 2 times 5 is 10, so I want to switch the order of these so I can put the 2 and the 5 together. And 2 times 5 is 10. 10 times 4 is 40. 2 times 6 times 1. Well, we can group 6 times 1 and go 2 times 6, which is 12. 2 times 9 times 3. Okay, I'm going to change the order and go 2 times 3 times 9. So I switched the order of the 3 and the 9 using the commutative property. And now I'm going to group the 2 times the 3 and get 6 times 9. I know 5 times 9 is 45, and 45 plus 9 is 54. So I used a factor I knew, 5 times 9, and then I added the extra 9 because there was 6 9s. 2 times 7 times 2. So again, I want to use the commutative property to switch the order of the 2 and the 7. and then I'm going to group the 2's. 2 times 2 is 4. 4 times 7 is the same as 2 times 7 doubled. 28. All right, find the unknown factor. 7 times the product of 2 times something is 56. Well, let's figure out how many 7s it takes to get to 56. 7, 14, 21, 28, 35, 42, 48, 56. So 8. 2 times what is 8? 4. 30. 6 times what is 30? 6, 12, 18, 24, 30. 5. Okay, so how do I get a product of 5 here? The only way to do that is to put a 1 there. 5 times 1 is 5. 6 times 5 is 30. 2 times 2 is 4. So 4 times what is 32? Count by 4s. 4, 8, 12, 16, 20, 24, 28, 32. So 8. So the missing factor is 8. 42. 7 times what is 42? 7, 14, 21, 28, 35, 42. 6. So 7 times 6. So this has to have a product of 6. 2 times what is 6? 2, 4, 6, 3. 8 times what is 40? 8, 16, 24, 32, 40. 5. So 5 times what would give us 5? 1. Okay, in this one, 34, we see our product is 0. Well, we know that the only way to get 0 is to multiply or have a factor of 0. All right, so 2 times 9 is 18. 18 times what is 18? 1. 6 times what is 60? 6 times 10 is 60. So 2 times what will give me 10? 5. 4 times what is 24? 4 times 4, 8, 12, 16, 20, 24. 6. 3 times what is 6? 2. Use the graph for numbers 38 and 39. Okay, so we have roller coasters here, and it says cars per train from 0 to 7. King de Ka has 5 cars per train. The Steel Force has 6 cars per train, and Mr. Freeze has 4 cars per train. All right, so each car on the Steel Force train has 3 rows with 2 seats in each row. How many seats are on the train? Draw a quick picture. Okay, so 3 rows of 2 would be 1 car. On the Steel Force, there are 6 cars. All right, so let's break this up. We have 3 rows, 2 seats on each row. And so we looked at steel force and saw that it has 6 cars per train. So we drew the 6 cars, 1, 2, 3, 4, 5, 6. And in each car, there are 3 rows of 2 seats. So we'd have 6 times 3 times 2. And 6 times 6 is 36. 39. A King to Ka train has 4 seats per car, but the last car only has 2 seats. How many seats are on one King to Ka train? For the King to Ka, we notice that it has 5 cars per train. 5 cars has 4 seats per car. So the first car has 4 seats. The second car has 4 seats. The third car has 4 seats. The fourth car has 4 seats, but the last car only has 2 seats. So let's see if we've drawn this picture right. King to Ka, 5 cars. 1, 2, 3, 4, 5. Has 4 seats per car, but the last car only has 2 seats. Okay, so we have 4 seats in every car except for the last, which has 2. So what does our drawing show us? It shows us 4 times 4 plus 2. 4 times 4, 4, 8, 12, 16, plus the last 2 gives us 18 cars, or 18 seats. Sorry, not cars. Each week, Kelly works 2 days for 4 hours each day and earns $5 an hour. Len works 5 days for 2 hours each day and earns $4 an hour. Kelly says they both earn the same amount. Does this statement make sense? So Kelly and Len. Kelly worked 2 days, 4 hours each day, and $5 an hour. So 2 days times 4 times 5. Len worked 5 days, 2 hours each day, for $4 an hour. Okay. So 2 sets, 2 days of 4 times 5. 4 times 5 is 20. 2 times 20 is $40. 5 times 8, 8 sets of 5 is 40. It does make sense. $41. Clayton packs 3 boxes. He puts 3 lunch bags in each box. There are 4 sandwiches in each lunch bag. How many sandwiches does Clayton pack? Show your work. 3 boxes, 3 lunch bags in each box, 4 sandwiches in each lunch bag. So if we draw 3 rows to represent the 3 lunch bags, and he put 4 sandwiches in each lunch bag. So this is 1 box, the second lunchbox, and then he has a third box that has also the same amount. Okay, so in our array, we have 3 by 4, 3 by 4, 3 by 4. So we have 3 sets of 3 times 4. So we could just add these all up. 12 plus 12 plus 12. That's what 3 times 4 would be. 12 times 3. So 3 sets of 12. 12 plus 12 is 24. 24 plus 12, 36. So some of you might have looked at this and said, well, I don't know what 3 times 12 is. So let's do 3 times 3, which is 9. And 9 times 4 is the same as 9 times 2 doubled. So either way, you can do that way. Okay, so you'll now do your online practice for lesson 4.6. Remember to use your textbook and the video to help you. If you have any questions, you can stop and ask me. Tomorrow, we're going to talk about patterns on the multiplication table.